We're going to do a couple more things involving circles, namely arc length and sector areas. And so you do need to know that anytime you have any kind of geometry problem involving circles, you can always end up with exact answers that contain the irrational number pi. As an example, an exact answer for a circle would be 2 pi. And if you want to approximate that, and instead of write 2 pi, write out the number that 2 pi is approximately, you would multiply 2 times the number 3.14, which you would get 6.28. And so sometimes when we want to write exact answers, we use the Greek letter pi as part of our answer. But in real life and practical applications, you probably want to use that 6.28 or what it was approximately equal to. So in this case, if we did 4 pi, it would be 4 times 3.14, and 4 pi is approximately 12.56. Either answer is correct. You just need to know what you're using for each particular one. If you were to use 100 pi, 100 times 3.14 will get you 314. So just know that if it's a circle problem, you're going to have to deal with that Greek letter pi either by writing it in your final answer if you want to be exact, or multiplying all the numbers that you have times 3.14 to get what the approximate answer is. Approximate is what you would use in day-to-day life and applications. So as we get started, we're going to get ready to talk about arc length, but we need to get you reminded about a couple of formulas. Here I've been given a circle. If I want to know the distance all the way around that circle, I need the circumference, and that's what the distance around the circle is called. And so the circumference of a circle is that blue arc. I start and I go all the way around the circle until I get back to where I started. That's called walking the circumference of the circle. It's just a distance around the circle, but I can write it as a formula by saying C is equal to 2 times pi times r. And the reason that's an important formula for me that you've probably already used before in other geometry settings in younger classes is because we're going to use this part of the formula to help me figure out this idea that we call arc length. And so suppose I want to know what the arc length of a circle. And so in this particular case, I've split the circle into 2 arcs. You can see the black arc that's big and goes almost all the way around the circle, but I've also given you the blue arc. And I've given you an angle that's marked there and then a radius. And so the arc length formula can be found by saying x over 360. And the reason that I put the x over 360, that's where that angle is. It tells me how much of the circle that I'm using. And then notice the end of the arc length formula looks just like the circumference formula. It's times 2 times pi times r. The reason that the x over 360 is there is because that tells you how much of the part of the outside of the circle that you're using. And then you multiply it times the whole circumference, and that will give you what this particular arc length is here, what that little piece is equal to. And so we're going to do a couple of examples, and then you're going to have some that you're going to practice on. And so in this particular problem, you can see it says calculate the length of the arc from C to B in the counterclockwise direction. Okay, our final answer, when you look at it, it's going to be a weird decimal. And the reason is this 53 degrees would give me a weird decimal, and we can have that. Just understand that that's going to happen from time to time on these circle problems. So the way that I would start this problem is know that I'm looking for that part of the circle, that little red part of the circle, that red curve on the outside of the circle. I'm looking for this part to this part right here. And so all I'm doing is I'm using that particular formula. The arc length is equal to x over 360 times 2 times the pi times the radius. Now I know that x is my central angle that I'm using right there. That's 53 degrees. And I know that my r is the 6 centimeters. So I'm just plugging these numbers into the formula to obtain the actual arc length. And so basically, now that you plug those numbers in, you just multiply them all together, and that tells you the length of that particular piece of the circle. And so in this case, my arc length on this problem is approximately 5.54. And notice that I use the squiggly lines. It's because I'm dealing with that number pi. And because I'm dealing with that number pi, my answer is approximately 5.54. That's good enough for you to solve the problem. So the length of the red arc is 5.54 centimeters. Okay, so what I'm going to do on the next slide is I'm going to ask that you that you figure out what the arc is in that picture. So take a look at this picture. I want you to find the length of the blue arc, given that you see that particular angle there and you see the particular given radius.